Hello, all of you. Very nice. Today we are going to see a topic on emulsification. Myself, Gurumukhi, I am working as an associate professor in the Department of Food Process Engineering, SRM Institute of Science and Technology. So, in this session, we are going to see the following contents: introduction, classification, type of emulsifiers, and emulsification methods, and its industrial application. So we all know that emulsification from long time, but we wanted to look out in a different perspective. So emulsification is the process of mixing two immiscible liquids such as oil and water to form a stable mixture, usually with the help of an emulsifier. So the emulsifier reduces the interfacial tension between these two phases. Thereby, it stabilizes the emulsion and preventing the phase separation. The following picture depicts that there are two bottles where we can see the presence of water and oil in one bottle. They are separated in two different phases, but they are not emulsified. If you add emulsifier in this bottle, you can see the mixture of two miscible liquids together because of the emulsifier what we added. So that is the advantage of emulsifier in emulsification technique. So now, having said that, we wanted to know how do we classify the emulsion. So emulsion can be classified based on its phase composition and based on droplet size. On the basis of phase composition, it can be classified into three different categories. That is oil in water emulsion. That is oil droplets dispersed in water. Example: milk, mayonnaise, and oil in water water and oil emulsion, that is water droplets dispersed in oil, for example, butter and margarine. Next, multiple emulsion, that is water emulsion or oil emulsion, which gives complex emulsions used in very much in pharmaceutical and cosmetic industries. So on the basis of droplet size, it can be classified into macro emulsions with a range of zero point 0.1 to 100 micrometer, which are in opaque appearance. Thermodynamically, they are unstable. Example, we can see in the case of common milk, sauces, and creams. And micro emulsions, droplet size range between 10 and 100 nanometer, which are transparent and thermodynamically stable, which requires high surfactant concentration. And lastly, nanoemulsions with a droplet size of 20 to 200 nanometer, which are all transparent and to translucent. Having said that, we like to see the type of emulsifiers. So based on origin, we can classify or we can categorize emulsifiers into three different categories: natural emulsifiers, synthetic emulsifiers, and particle-based emulsifiers. So natural emulsifiers are biodegradable. Example, lecithin, which is found in egg yolk, soybean, which are very much usage in chocolates and biscuit, etc. And milk protein, example, casein and whey protein, they stabilize dairy emulsions. On the other side, polysaccharide emulsion, that is based on gum arabic and pectin, which are in very much usage in beverages and sauces. And synthetic emulsifiers, which are having high efficiency and which are having wide application in industrial sector, which includes mono and diglycerides, which are very much application in backed goods. Polysorbate, for example, polysorbate 80, which is having very much application in ice cream and cosmetic industries. And the sodium stearoyl lactite, that is the another SSL emulsifier, which is having number E481. It is a versatile emulsifier which is having wide application in backed goods and other processed foods to improve its texture and to enhance the volume and to extend shelf life. And another one emulsifier, that is particle-based emulsifier, which are also called as Pickering emulsifiers. So they are all solid particles which stabilizes emulsions and also acting as a physical barrier at the oil-water interface, so that it prevents coalescence and also flocculation. It has got various applications in food industries, cosmetics, and pharmaceutical industries. So, for example, starch, silica, cellulose, which are all in common applications. All these emulsions are taken care by regulatory bodies such as FSSI and FDA. These bodies approve these emulsifiers with approval usage limits and considering the safety aspects. Having said that, now we move on to the methods of emulsification. Before that, we want to see hydrophilic lipophilic balance and other aspects of emulsification. So based on the HLB value, which determines whether emulsifier is more water or oil soluble. low HLB, that is low hydrophilic lipophilic balance, less than or equal to 6 forms water in oil emulsions. Example, butter and margarine. High HLB, that is high hydrophilic lipophilic balance, greater than or equal to 8 forms oil and water emulsions. Example, milk and mayonnaise. And intermediate HLB, on an average 7, can work both in water oil emulsion as well as oil water systems. Now, why emulsifiers are needed? Oil and water are immiscible due to difference in polarity. Water is polar in nature, whereas oil is non-polar. When they are mixed, they tend to separate due to its high interfacial tension. So emulsifier reduces this tension and stabilizes the emulsions by forming a protective layer around dispersed droplets so that it prevents them from merging and back together. So that is the advantage of emulsifier. So this is the picture which shows the ultrasonic homogenizer. By having this ultrasonic homogenizer also, we can make the emulsification. So we like to see the science base behind the emulsification. The formation and stability of emulsions depend on interfacial tension and emulsifiers. So interfacial tension and energy input, oil and water naturally separate due to high interfacial tension, whereas the mechanical forces, shear, homogenization, ultrasonication are needed to break large droplets into smaller ones, increasing the surface area. So more surface area means more energy is required, which is counteracted by emulsifiers. So the role of emulsifiers includes, which stabilizes emulsions by forming a protective layer around droplets, preventing its coalescence. They contain hydrophilic head, which is water attracting, hydrophobic tail, oil attracting. This allows to position themselves at the oil-water interface, reducing interfacial tension and stabilizing the emulsion. If you look at this pictorial representation of the emulsion, here you can see oil droplet, inside the oil droplet, outside you can see the water. There the emulsifier acting as the protective layer, and we can see hydrophilic head and hydrophobic tail. So now we like to see methods of emulsification. So there are two different type of emulsification techniques are normally being followed in various industries. One is mechanical methods, another one is chemical methods. So depending upon the emulsion type and stability requirement and its application. In mechanical methods, high shear mixing breaks down droplets using mechanical force, for example, blenders and homogenizers. In the case of ultrasonication, it uses ultrasound waves to create nanoemulsions. High pressure homogenization also being used in industries. It forces liquid through a small nozzle at high pressure, reducing droplet size. In the case of chemical methods, phase inversion emulsification, that is changing the oil to water ratio to switch between oil water and water oil emulsions. So sometimes spontaneous emulsions also being taking place. Emulsions form without mechanical force using specific emulsifier properties. So now let us see what are the factors affecting emulsion. So mainly temperature. Temperature influences viscosity, solubility, and emulsifier effectiveness. At high temperature, oil and water phases mix more easily due to reduced viscosity. But excessive heat can degrade emulsifiers, for instance, protein denaturation, polysaccharide breakdown, etc. So that the excessive heat or temperature definitely affecting the emulsification. On the other side, lower temperature can cause phase separation, that is flocculation or coagulation, due to the increased viscosity and reduced molecular moment. On the other side, pH. pH affects emulsification, especially when proteins or polysaccharides are used as emulsifiers. Acidic or alkaline conditions can increase charge repulsion, stabilizing the emulsion. For example, soy protein isolates are effective emulsifiers at a pH above their isoelectric point, on an average pH 4.5. And agitation and mixing. High shear forces break down droplets into smaller sizes, improving stability. Homogenizers like high pressure homogenization provide uniform droplet distribution, enhancing emulsion stability. Overmixing can also lead to droplet coalescence due to excessive mechanical stress, causing its instability. And particle size and distribution is a very important phenomena. Smaller droplets increases surface area for emulsifier absorption, enhancing stability. Mono dispersed emulsion, which gives uniform size distribution, are more stable whereas polydisperse emulsions, which are having varying sizes, may lead to creaming or sedimentation. Techniques like microfluidization and ultrasonication help achieve finer and uniform droplet size. In this picture representation, you can see the monodisperse emulsion and polydisperse emulsion. You can see the difference between these two types of emulsion in a graphical manner. So, having said that the method of preparation and factors affecting the emulsification, now let us see what are the applications of these emulsification in industries. We have got wide application in food industry, agrochemical industry, paints and coating industry, cosmetic industry, and pharmaceutical industry. In food industries, emulsification blends immiscible liquids in food products. In agrochemical industry, emulsifiable concentrates reduces runoff. Say for instance, I can tell you one example here. Nowadays, urea, it is coated with neem oil so that the sustained release of urea being take place so that it will not easily run off from the soil. So that is one of the advantage of coating urea with the coconut oil, neem oil. Likewise, the other applications also is there in the case of emulsification. In the case of paints and coating industry, emulsification of pigments and resins are having advantage. In cosmetic industry, emulsion stabilizes the creams and lotions. In the case of pharmaceutical industry, emulsions enables controlled drug delivery in the case of ointments and creams. In the case of application of emulsion in food industry, for example, we will see in the dairy sector, it has got milk, cream, ice cream, and cream. Milk is a natural oil-water emulsion. Fat globules are stabilized by casein proteins. Cream has varying fat content, 10 to 40%. Homogenization prevents fast separation. Ice cream is a complex emulsion. It contains fat, ice crystals, and air. So emulsifier control ice crystal size. In the case of bakery industries, margarine, cake batter, bread making, or we can see as an example of emulsification. Margarine is a water in oil emulsion. Solid fat content influences its plasticity. Cake batter is oil in water emulsion, is a multi-phase system. It is used for increasing the crumb structure and also retain the moisture and mainly to extend the shelf life, and beneficially it also aids in flavor and aroma retention. In the case of bread making, emulsifiers strengthen the gluten network so that they improve the dough handling and low volume. Now let us see the challenges and innovation in food emulsions. Mainly stability issues, clean label emulsifiers, and nano emulsions. In the case of stability issues, common issues include coalescence and flocculation. Asphalt ripening is also another challenge. Asphalt ripening is a phenomenon in solid or liquid solutions that describes the changes in inhomogeneous structure over time. So small crystals dissolves and redeposit on large crystals. So this phenomenon is called asphalt ripening. So that's also a challenge in the case of emulsification techniques. There is a growing demand for natural alternatives. So options include lecithin from sunflower or rapeseed. Nanoemulsions also rise in the industry nowadays. Nanoemulsion enhances bioavailability. They also improve texture and appearance. Now, having said all these things, we like to see what is the way forward and future trends of emulsification techniques in these industries. So, first thing is clean, label, and natural emulsifiers. There is a focus on plant-based and sustainable formulations and emulsions with enhanced bioavailability for various industries. With the usage of artificial intelligence and machine learning, we can optimize the formulations and predict stability. And in the case of sustainable concept, eco-friendly processes and methods to reduce environmental impact. And smart emulsions sensitive to environmental changes for controlled release. So they act as a smart emulsions. And largely, exploration of zero waste and functionalized emulsions are on the rise in the future. With this, we can conclude this session. We will talk more about the various preparations of emulsions and application of emulsions in coming days. Thank you for your patient listening. Thank you.